We're going to open a new project. We'll produce these control points here. If you want, you can save it. You can choose your hull type. At the moment it is chine sloop. It generates a hull for you automatically, and you have the ability to control any and all of these points here. So moving these will change the shape. And probably not a reverse shear, so these points could go down. So a more traditional boat. Transom and bow I'll explain a bit later. A chined boat. And I'm just going to retrieve a boat that I've already created, because otherwise it takes a bit of time to get everything configured. So if I revert now to a previous design, this has got some additional details in it which will be useful later on. So for example, using this curve here, you can create a shaped bow. You would just say select bow profile, and you can do the same with the stern, whatever shape transom you need. So we'll just create a transom curve. And you can obviously change the transom camber, you can change the chine height in the bow programmatically. In other words, it's a percentage of this, our bow height. You can change the stern height, you can increase the chine width, you can change the chine angle. This is more useful on power boats. You can also add shape to the top sides. This is sort of a percentage down in the bow, a percentage down in the stern, and a percentage increase in beam. So the lines will appear first. I've got lines switched on by default, which slows things down considerably. So there you've got a topside shape. And if we don't want it to have a kink, we will just change it from, say, to a loose shape, which will then just give a bit of roundness to the top side. So it might look a bit odd on a boat like this. So there you have it. So kind of odd. Let's just switch it off again. At this point, if you want to get the hydrostatics, you would switch on the immersed properties. And this will obviously do a full hydrostatics of the boat to the data waterline, which is the XY plane at the origin. It gives you a sectional area curve. And if you're confused about the control points, you can switch the naming convention on. So it basically puts a name on every point. And that is your vessel. You can extract the panel sizes from there, but obviously it produces a bill of materials as well. So this is really just for early quotation purposes, so you can compare deck areas and hull areas as you make changes. So let's just switch them off. In fact, let's switch off the immersed as well. It does slow things down a bit. And the lines. The lines, if you want the lines, you can change the spacing here. So woodline spacing is currently set 25 centimeters. Station spacing at 1 meter. We make it 0.5 meter. It just gives you more detail and slows the process. But there is a complete line plan. If you go into the 3D views here, you will then have sections, buttocks, waterlines, and a 3D view. And this obviously you can just generate a static lines plan very easily. All right, switch off the lines plan, and then we will have a quick look at the structure. So all the modules that are available are here, and you switching them on or off, depending on what you want to do. You can create a multi-hull from this hull. You can do all the engineering, tankage, and so on. You can do live buoyancy flotations, but what we're going to do is just switch on the structure, which is called Gravity 1. And this will open a window, and down here you choose whether you want this as metal, fiberglass, cord fiberglass sandwich structure, or wood. Solid fiberglass will come a bit later if people still want to do that. There doesn't seem to be much demand. So what you have here is you have the laminates that you can create. So you would choose an outer laminate, a core thickness and density, and an inner laminate. And you build up a set of laminates now, which are obviously going to be reusable in a yard. In aluminium, you would have slightly different. You would create all the available thicknesses of the string extrusions, extrusion heights, flange widths, and so on. And then that becomes available when you go to, and there's steel as well. When you go over here, you would then be able to choose, depending on what you've picked here, you'll be able to choose all the materials just by dropping them down. So frames, for instance, are set up here, floors here, the flange plate width, bulkhead, sole. I won't go into a lot of detail here. It's fairly self-evident. And here you've got a thing called visibility, which basically switches on all the structures as you want them. So what it does, let me switch on the labels, is it actually uses layers. So it will create basic frame spacing. You put in the frame spacing you want here. So this is about 138 centimeter spacing for some arbitrary reason. And those are created on the layer frames. And if you want to, just move this, if you want to change a frame and make it a watertight bulkhead, you would just go in here and change to the layer watertight bulkhead. And then in order to see them, you put the layers on. So bulkheads are bulkheads. Watertight bulkheads are not pierced by stringers. And this is a standard bulkhead, this is a watertight bulkhead, that's a standard bulkhead. Frames are produced similarly, flanges on the frames on an aluminium boat. And you can choose whether the flanges are T flanges or L flanges. Floors can be added, like in way of the keel. Let me just go back into this view. It creates cutouts in the floors automatically. You need that for bilge pumps and so on, and really is excess weight. Soles you can add. So this is basically going from there to there, but you can change that. And you're going to say that the sole height is 30 millimeters above datum, and the rat hole radius for aluminium boats is 31. And the sole, if we go in here, the sole extends from this frame to this frame. So there. And this then will work out. The sole, by the way, is pre-built here under your laminates. And typically it would be a plywood sole with perhaps a layer on either side. So now you've created the transverse structure. Plating, you can add, if you want to add cutouts and plating, you can do it here. You're basically just choosing openings, select openings here. Spacing of the stringers in an aluminium boat, obviously you can see the notches are cut for the stringers. What type of support it is, flat bar, T-bar angle, and how to divide it from the centerline plane, from the shear line, etc., etc. And this is the actual stringers which were created earlier. So that's the stringer section. So there's a 25 by 18 by 4 millimeter T-bar aluminium in 54 on 5083 alloy. Same with topside, same with canoe body, and you can divide the canoe body into keel plating, and you can divide the topsides into two different thicknesses, particularly on a rounder bilge boat. That's important. Let's go back to visibility and you switch on some more stuff. Plating will show you all the various panels that are coming out, which we saw earlier. Stringers produce stringers according to your specifications, and these are T-bar, well, they're whatever stringer you've chosen, and each panel you lay them up in a different way. Obviously you have to support the plating, and if you switch on weight, it'll give you a total weight of the entire structure as a label. Let me switch off the controls because they're just getting in the way now. So there you have a structure of a boat. I mean, it's not particularly good, but it's got floors for the keel, it's got frames, it's got bulkheads, and you have a running weight of bulkheads, hull plating, frames, so on and so forth. And you get a bill of material breakdown, which is useful for when you're ordering equipment. So that's just the metal structure. And obviously this is a sailing boat, so let's quickly show you the rig. So that comes under modules over here. Modules, I'm getting lost. Modules, and that comes under performance. So on a planing boat, performance includes steps and rails, spray rails, and so on. In a sailing boat, a displacement boat, it can produce a rig for you, but it'll also take care of appendages and rudders and so on. So it's produced an arbitrary rig. We'll leave that for now. Let's just look at appendages. So appendages require a keel leading edge. Pick that. Keel trailing edge. And there is a keel. I've left it like that because I'm going to add a bulb now. Let's just quickly do the rudder. So there is a rudder leading edge, trailing edge. You can, if you wish, move the rudder. You could move them off center, let's say, to there, and mirror them. I think I have messed up the transom, but let's just leave it for now. Any of these amounts, you can double click here and just type in the number. It's much quicker. So now we've got twin rudders, a fin keel. Let's just add a bulb. So a bulb requires a center line and the ability to actually have a slightly curved center line means that the bottom can be flatter than would be traditionally normal. Ballast. Bulb center line is the line we just drew. The flat tail factor just widens the back of it, show you here, back of the bulb. And obviously your aspect ratio, so you could make it wider than it is high or vice versa. And then the knacker sections basically thicken up the bulb. If you want a really big bulb, you can take that to 18%. And now we'll just quickly work out the ballast and you can see the effect on the ballast. This is like a 15% thickness chord ratio. That's a bit big. Anyway, let's quickly draw a ballast line. It's out of the way, everything's in the way, of course. So if this was a bolt-on keel, you would possibly have a ballast line. It can look anything you like. It must be in a plane. And then you would say ballast line, pick that. Obviously, if it's a fill-in keel in an aluminium boat without a bulb, you would just draw a keel and then put the ballast line in. And then later on, I'll show you how you change the hydrostatics because that would be full volume. So now the ballast is now calculated. It's 1.5 tons more or less. We'll fair this off and make this root a bit stronger, but that is effectively and appendages. I think we've got something on here. So this is going to add the keel root to the vessel, which means that if it's, for instance, in an aluminium boat, this will be part of the vessel, and then this would be the bolt-on piece. If in an infill, say you would add the keel to the boot, and if you have a keel that bolts on flush to the bottom, you would just put none in here. This affects the hydrostatics as well. So now we've got a somewhat weird bulb keel, and let's just do the rig quickly. So the rig needs to be manipulated. It sort of starts off with a pretty basic rig, and you do have to line all the points up so that you've got realistic rigs. This is very useful to get weights out. It'll actually calculate the weight of the rig with the sails up, and you can then check your riding moments, things like this. So I'm just going to we don't need a bowsprit on this boat. Oh, we do, but hey. The rig is here, and you've got control over it in multiple ways. At the moment, it's not showing the controls. You can switch those on, you'll see it makes life a bit easier. Gooseneck, foresail clew, mainsail clew, and so on. You can move them around. It's already worked out the weight of the rig, but let's just neaten this up a bit. I'm going to switch those off. If you want, you can get the areas and the center of effort and so on. So geometric center of effort, and the actual center of effort of the rig, they vary a bit. Quite useful to have. Let's switch off the weights for now. These are the mast sections. So you have a standard set of mast sections. Whoever the supplier is near you would give you these sections, and by putting them in the asset library, you would call it up boom section, spreader section, and the forestay section. So, for instance, if you wanted a carbon mast and an alloy boom, or let's say a carbon boom, but alloy, you wouldn't do this. Alloy carbon spreaders. Okay, we should see the weights came down. Spreader count. This is a 3-spreader rig. 3-spreader rig. It has got. This is the distance from the caps. This is the distance to the forestay. This is the bury of the mast. The mast is burying now 70 centimeters. That would typically be more like 1.4. I mean, this is quite a low-profile boat, so that would probably do it. And then obviously it adds the weight to the mast. The masthead length gives you the ability to put a bit of a crane on the mast. At the moment it's set to 0, probably because I was doing a multi-hull, so let's just set it to masthead length. Let's just set it to something realistic like 50 centimeters. So there's a masthead with a backstay. Now this is going to have a problem, so we go into the sails and we say the mainsail headboard length is probably realistically more like that, so it'll end tack inside. Let's put the backstay where it should be. So this point here is where the backstay chain plate is, and if it's a single backstay, just put it on the center line. Now we have more or less a rig. Let's just quickly. So at the moment, this is again a multi-hull rig, so we need a say double lowers, which are more realistic than this. And then let's just make the spreaders a little bit wider. So that's the chain plane position for the diamonds. Just have to grab that point. I'm going to move it out to that frame, out to the side of the boat. Now we're seeing that we're hitting the sail here. So either the sail has got a sheet outboard, or we can move this screw slightly forward. So there we go. That sort of thing will do it. Or we can increase the sheeting angle, which is not great. So this is 11 degrees. Okay, 12 degrees. Won't really matter much. If you want to cut a rig, you would switch on the cutter, and this will produce a staysail. So it did have an inner forestay before because of the fact that it is a cutter rig in the configuration, but now we've got an inner stay. So the staysail overlap is 0%. If we make that 90%, it'll generate a staysail. The height is this thing here. Let's make it a little bit higher. Okay, so that's a reasonable rig. Boom could be a bit longer. Yeah, we've lost the other points now. I'm not quite sure why that has happened. Just put it back quickly. So that's a reasonable rig. And the main thing is you can get a weight. So this is the structural weights. That's the sole weight, which is secondary assembly. You can add partial bulkheads and extra floors and all sorts of things into the secondary assembly. The ballast is 1,500 kilograms. The sails and battens are 126 kilograms. Spars and rigging is 473 kilograms. Seems about right. We'd have to check all of this, of course. But there's a boat with a rig and a keel and a ballast, and it's taken what? It's here. So under config, so config is your length overall, the beam ratio. This gives you a beam and a depth, and if you change these, you'll reset your point. So you want to set that up in the beginning. But under visibility, if we switch on the immersed measurements, we get a 4.2 tons. So this is a little bit on the light side. What you would do is move the whole boat down to effectively move the water plane up, and it'll recalculate. And it has recalculated everything. Here's some sections. And here is a weight of 6.366 tons. Normally this would be quite an exhaustive set of doing and frying. And of course, because it is parametric design, we can at any point go back and change any of these dimensions, the frame positions, the forestay overlap, the let's make the bow profile. We can't really do that. Make the transom a bit narrower, and this will update live. So it's 6366. That won't really make much difference, but the weights have changed. Let's say we want to make this 4 foot a bit because it's got a bit of a hollow. We'll grab the 4 foot point. We'll move that out a bit. This will make the volume higher, and it will move the LCB, and it'll also change the angle of entry, and it'll change all of these automatically. So we're now at 6.58 tons, and that seems reasonable. I'll end here and we'll carry on with multi-hulls later.